My name is Lola Dukowski, and I did not type the funny part because the B key on my computer doesn't work that well. And I will be presenting both of my math and my chemistry PowerPoints and PoL things, and I'll be starting with math, which looks the best. Too. So this is my homework completion chart. Pay no mind to these 3 ones that I couldn't get rid of, because I had to refill this thing out. I did not complete all of my homework, as you can tell with these 2. I got 2s on these. But even the ones I didn't do, I pretty much usually understood, probably because I already took geometry ones. So it's mostly just I was being lazy and I didn't complete those. I'm going to be honest. That's what happened. Or I lost my book when we were turning those in. And this is my assessment score completion chart. I did not complete all of my corrections, though I did complete the thing with the C quiz. That means correction. I had to wing it a little bit there. I did not complete at all for the test, because I didn't. This is actually my lowest quiz for this part, which is impressive for me. I'm happy that that's the lowest score I have on a quiz. So I didn't complete most of my corrections. I did use a lot of my notes, and from this year and last year, because I have really in-depth notes from last year. When I did corrections, I don't have a lot of people help me. I do better if I just sit there and try and figure it out for a while. And if you do have to ask for help, it's usually when I have absolutely no idea what I did. Usually those are also followed by a picture of a cat, because that's what I draw when I'm confused. I'm not joking, I've been doing that for years. I draw cats if I'm confused as a problem. Things I did to improve my grade, which I'm happy with my grade in this class currently. The main thing I tried to do was get good quiz and test scores, because I know for a fact I'm very bad at doing homework and I really hate doing it. I absolutely hate homework. I also look at notes from my old school because they tend to be more thorough because I just learned it, and now I'm kind of going back to it, though there's still things at that school where I was like, what is this? And I'm like, oh, I get it now. So this is the analysis of my semester. I believe I like my current grade. It's an A-, which is good for me. I get good scores on my tests and my quizzes, but I am not that good at homework. I do understand the context extremely well, especially for this one, though I'm going to have to study a lot harder in Algebra 2, because I won't have prior knowledge to it. And I'm fine with my current grade. I think it's great. It's fine by me. I've misplaced my notes, so I don't know where the LT part, but I can probably tell from the problem. I'm just bad at understanding that part. My lowest essential skills thingy was number 1, and my lowest quiz is quiz 2, which is still not that low, luckily. And my problem is mostly just simple mistakes. I'm also really overconfident in what I'm my work, even when it's probably wrong. I'm just way too confident in what I'm doing. Sometimes it's good, sometimes it's horrible. But I also forget what things are called. I'm horrible at memorizing things. I memorize things, but it's like, what is this called? And I'm like, I don't know, but I can tell you all of the different properties of it. So this is my quiz problem, and I'm going to correct it by just telling you. The problem was I mostly kind of forgot what things were. it looks like an isosceles, and I didn't understand with this one that it was drawn to scale, so I could just measure it and like, it looks right. Though sometimes I do just mess up completely which one I'm saying. It would be like scalene, and I say everything that was I do the whole definition for isosceles, and I'll say scalene. And there's things that I do like that sometimes. Usually not on quizzes, but I just do those randomly if I'm like working on homework. So the thing that I messed up on is it should have been isosceles. I got this problem right, and this one had, it was just telling which sides were, what the triangles were by their sides, and honestly the side ones are the ones that confuse me more for some reason. Don't know why, they just kind of are. But I also, because I feel like overachieving, I also wrote the ones that were like, and here's how it is in angles too. Overachieving only in math. Because it's the only one I know I can actually kind of overachieve in sometimes. And I don't have any more examples because I didn't get very bad scores on tests and quizzes. And that was the only one wrong on that quiz. Now on to the Chem one, which I'm kind of ashamed of what the PowerPoint looks like. Because I had to, I'm really ashamed of how bad this looks. So, I'm in atomic structure and nuclear chemistry, and I don't remember entirely what the score I got on the test was for this. I feel like it wasn't bad. It probably was good, considering I don't get very bad grades in chemistry. But in all honesty, sometimes I just forget what these things are, especially with radioactive decay and the alpha, beta things. Again, formulas confuse me. I don't memorize things well, or even if I do, I forget which one they're with. So these are the different sections, and I did not title them how they are before. I just kind of titled them what would help me, how I go easier. So the molecular structure, the nucleus of it is made up of protons and neutrons, and I feel like drawing stuff. So, and most of the atom, 90% of the atom is empty. It's all empty space. Though all of the mass of the atom is in the nucleus, which also means electrons just don't really weigh anything. But protons and neutrons, they're heavy. They're intense. They're very intense. And just for always knowing it, the protons are positive, the neutrons are neutral, the electrons are negative, and they would be way cooler if they were negatrons. Yes. They would be so much cooler. It sounds like a villain from Power Rangers or something, or Sailor Moon. Experiments. The J.J. Thomson cathode ray. I did not elaborate on here, but I can elaborate now. There was this little tube thing. This is going to look like a horrible drawing. This is a horrible drawing. And he shot, it was a vacuum, and he shot these, he discovered the electrons. Mm-hmm. So he broke apart all these atoms in this thing and made this green light in here. And then he used a plate that was, one plate was positive and one was negative, to discover that the little particles were in fact negative, and that's electrons, and I really wish they were called negatrons. It would have been so much cooler. And the Rutherford Guilford experiment was how he discovered the nucleus, where he shot a bunch of little molecule atom thingy particles stuff at this piece of gold foil, and 90% of them went straight through. Fine, that's what he thought it would do. But 1% bounced off, and they went on crazy directions. And because 1%, they have to be something that it bounced off of. And that was the nucleus. It was super dense and it could block things. That's how they discovered the nucleus. And there was another guy who I forgot the name of right now, who discovered that there was like what was in the nucleus. Protons, neutrons. Chadwick. That's his name. I forgot his name. Again, I'm terrible at memorizing things. I feel like I skipped. Nope, I didn't skip something. I thought I skipped something. How the protons and neutrons in the nucleus are held together. They're held together by nuclear strong force. Because if they didn't have that, they would just break apart. Because protons don't want to be with protons. It's all positive, they want to repel. Which is also how radioactivity works. If there's too many protons, if there's too many protons, the want to repel goes over the amount of nuclear strong force there is, and it starts shooting protons out, which sounds cooler than it is, but it is still pretty cool. It'd be way cooler if it looked more like this, if you could see it doing this, or it's like, it looks like a gobstopper, don't worry. It kind of looks like the face of a diglet, and it shot out a bunch of protons. These are comparable to what you draw when you're presenting.
Hey, great artist.
Yes, great. That's why you're teaching chemistry and not art.
Hey.
I'm sorry, it's too easy to joke.
I know.
So, radioactive decay. There's 3 kinds. There's alpha, beta, and gamma. Alpha's formula, and it has this symbol that I did not use here because I don't know how to get into the PowerPoint. I think it's this one. I think. It's either this one or this one. This one. I don't remember.
The one on the right's alpha, and the one on the right, or the one on the left is gamma.
Oh, that one. Yes, I get those two confused. They're really similar.
Yeah.
So this is the alpha picture. I believe it's Greek writing. And the formula thingy is 4/2. And alpha particles can be blocked by like cardboard, like paper and stuff. Like they're not hard to block. They're fairly weak. Beta is a little bit stronger. Its formula is 0/-1, and it looks like this. That is a terrible line. That is horrifyingly bad. Looks like that. That one I know.
Beautiful.
That one I know for sure which one it is. It can be blocked by like cardboard. It's harder to block than alpha, but it's still not that hard. And then there's gamma, which the formula is 0/0, so nothing really happens to it. It just kind of is intense. And gamma's one is the one that I previously thought was alpha. So it's this, and it can only be stopped by lead or concrete, which is really intense.
Yes.
Aggressive pointing.
Nice.
I feel like I'm going to like, and anime powers.
Oh my god.
And thank you.
Alright.
I discussed things.
Yes. Okay.
I'll
Cool.
pause the video.
Stop the video.
This is going